So someone noticed that in chapter 10, I gave you two problems and they seem like they're exactly the same. So in set A, problem 1, it tells you have students and they have midterm scores and they have final scores. And if you read it closely, you realize that the average in SC is the same for the midterm and final. Now that part is just pure coincidence that it's the same for the midterm and final. That doesn't really affect us any at all. You have a correlation and you're supposed to estimate the average final score for students with midterm score of 75. Now, that shouldn't throw off any bells. You should just say, okay, I use the regression method. We figure out how many standard deviations we were from the averages. We times it by the correlation, etc. Okay, so you do that and you find the average. But then when you get to set C, problem 1, it says estimate the final score for a student whose midterm score was 75. And it seems like it's the exact same problem. So what is the difference? Now, this is actually a really important difference, or just a really important thing for you to know. So notice when you read it, this one says estimate the average final score for students. And the next part says estimate the final score for a student. So notice there's a very big difference. The first one is the average for all the students who had a midterm score of 75. And the next one is find a final score for a student whose midterm score is 75. So those are two very different things. But the really fascinating thing is we do it the exact same way. So the regression method doesn't change whether you're trying to find the average or you're trying to find it for a student. You do the exact same thing. But let's talk a little bit more about that distinction. So when we look at a score of 75, which, let's see, 70 is probably about here, and I go up, notice there are actually quite a few students that had that midterm score of about 75. On this one data set that I actually made up to show you what it would look like, it looks like there are 1, 2, 3, 4, 5, 6, 7 different students that have about that midterm score of 75. Now, obviously, when you look at this, not all of those 7 students got the exact same score. That's never going to happen. Anytime in the real world, you always have variation. You always have changes between people. So for all of these people that had a midterm score of 75, if you find the average of all of these people that had a midterm score of 75, you would expect the average to be here on the line. So when you predict it, it's the point on the line. And you're saying, okay, this is what I think the average will be of these. Now, again, you always have variation, so the average at that point might be a little bit above the line or might be below the line, but you're predicting this point on the line. So you predict the average for all the people who got a score of 75. Now, you might also say John got 75 on the midterm. Let's predict his score. So to predict it, you find like where would the point be on the line, which we do just using the regression method, and then you predict his score. Now, we said you're going to do the exact same thing, so you are going to get the exact same answer. Which one do you think would be more accurate, though? Well, anytime you're predicting, your predictions for the average are going to be more accurate because the highs and lows cancel each other out. But John, he might have been a point up here, or he might have been a point down here, or he might have been a point close to the line. You don't really know. There's a lot more variability for John because he's just one person. He could be up or down, or who knows. But the average will usually be pretty close to the line. Okay, so again, it's really cool that to find either the average or for just one person, you do the exact same thing. You just do the regression method. You figure out how many standard deviations were you from the average. You times that by the correlation and then say, okay, that tells you how many standard deviations you should be from the average for the final exam score. Okay, so that's it. That was the difference. It doesn't make a difference what you do mathematically, but it's really cool that the same method works no matter which thing you're trying to find.